Okay. All right. So now that's what he's saying. So here, yeah, here diagram is there. So length of three sides of the trapezium other than the base. That means what three sides? This is one side and this is another side and this another side. Three sides other than base. 10 centimeters only. And what else? Find the area of the trapezium when it is maximum. So what is the question you do? See, now this is 10 centimeter, this is 10 centimeter. Yes, sir. This 10 centimeter, this also 10. It can be like this also, no? It can be like this also, no? Yes, sir, no? And it can be like,
Yes, sir.
this is also 10 centimeters, no? It can be like this also. Okay, but it can be like this also. This is also 10 centimeters, no? Right? It can be like this also.
Yes, sir.
And it can be like this also. This is also trapezium. It can be like this also. With all 10 centimeters only. This is all 10 centimeters. That means what? Fourth side is okay. This fourth side decides. Okay. To have maximum area or minimum area. So as you take like this, you are able to understand that if you take like this, like straight, it's going like this, it's going to minimum. Yes or no?
Yes, sir.
Area is 0. This is 10 and this is also 10, this is also 10. Three sides are like this. This is also trapezium. Fourth side is up on this only. So this is what is minimum. That 0 is a minimum. But maximum we need to find out. So but you can make it square, you know. You can make it finally it comes into square. That means three sides are 10, fourth side is also 10. That's also square is also trapezium. A square is a trapezium. A square is a rectangle. A square is a square. A square is rhombus also. Yes or no?
Yes, sir. Yeah.
A square is parallelogram also. All right. So now, okay, let's take this. Three sides are 10 centimeters, and then fourth side we have to assume. So fourth side is some, what he assumed here, fourth side, you know, because it is trapezium and this is 10 centimeters, then let's take this is some x and this is some x. That's a question now. Yeah, what is that we should find out? What is that? Find the area of the trapezium when it is maximum. Area we need to find out. So now the fourth side is required. What is the area of the trapezium? Area of trapezium?
Half into
Very good.
sum of parallel sides.
Into height.
Height. Okay.
That is what actually when you draw. If you draw like this, then you know this is some B, this is some A. You understand? This is some A.
Yes, sir.
Fear of all. See, this is what is, let's say, a trapezium. Okay, this is what is this is what is B. Okay, now we have to draw like this. If you draw like this, you get two triangles. This is one triangle. Let's say
Congruent triangles.
Yes, they're not congruent. Two triangles. That's it.
It's similar.
This triangle for this triangle for this triangle. I'm saying for this triangle.
Yes, sir.
Triangle. Okay. Area is what you know. Area is half into AH. For this triangle, because it's obtuse angle triangle, then the height will be outside, not the inside. You understand?
Yes, sir.
Now this is the base. You understand? This is the base. And this is what is height. The height will be same h only. You understand? The height is distance between these two parallel lines. It is same for this triangle and also obtuse angle triangle. So that area plus another area is what? Another area is half into B into H. Understand? Base is B.
Yes, sir.
Height is H same. Height is same. Okay, distance between parallels. So that is how you get half A plus BH. Okay, for triangle half AH. For trapezium half A plus BH. Okay.
Yes, sir.
So now let's take here because we have to take third side. Third side, whatever you take, this 10 will be there. This 10 will be opposite, right? This 10 will be there. So here this is if this is x, then this must be x. Why? Because here this is 10 centimeters, this is also 10 centimeters. That's what he said. This 10 and 10 only he said. Okay, when this is 10 and 10, then and this is parallel. Therefore, then you know this is x, then this also x. All right, now what we should do? Now we'll do in our own way because Here we have some square and all, but we take somewhat different way we do. All right, so area, what is area formula? We'll write the area formula. Area is of A plus BH. Okay, now according to this diagram that we have, this is 10, this is 10, this is 10, and this is what is x, and this is 10, and this is what is x. And this is what, what is this h? H is under root of n square minus x square. Yes or no? By Pythagoras theorem?
Yes, sir.
All right. So now h we write, and see like this, a equal to half of a is 10 plus b is 10 plus b is what?
Uh, 10 plus 2x.
What is h? H is what is this? 100.
Root 10 square minus x square.
Yeah, so we'll simplify this one. Half. Anyway, this gets cancelled because this is 20. 20 becomes 10 plus x times under root of 100 minus x square. Okay, but this one you can simplify as it is. Or, but if you simplify as it is, you are going to get a denominator, and then second differentiation is going to be u by v rule, which makes the problem complicated. So how to make it easy? Yeah, how to make it easy?
A square.
Good, a square. So if area is maximum, then area square also maximum. That is 10 plus x whole square into 100 minus x square. So now let a square equal to f of x. And you get if a is maximum, then a square is also maximum. That is the principle we are using. All right, now let that is already one. F of x is now. Yeah, you take that f of x and differentiate. F of x is f of x is f of x is 10 plus x whole square into 100 minus x square. And f dash of x is twice 10 plus x into u dash v minus u plus u v dash. Anyway, 10 plus x is common and 2 is common. And what is left? 10 twice this is common, so 100 minus x square plus what is left here? 110 plus x into 1 more minus x. This is what is left. 10 plus x into twice 10 plus x common. If you simplify this, 100 minus x square, 10 minus 10x minus 10x minus x square. So it's further simplifying. We get 100 minus 10x minus 2x square. Okay, this will be good. This is what is f dash. So further what we should do? Put f dash of x is 0 to find per critical point. So for that, what you get? 10 plus x is 0 or this one is 0. What is that? 2x square plus 10x minus 100 is 0. Either this is 0 or that is 0. But for first one, you can't say yes or no. The first thing you can't say 0. 10 plus x, 10 cannot be minus 10. So this is not possible. That means what? Here this one has to be 0. Second part has to be 0. That
Yes, sir.
x square plus 5x minus 50 is 0. So this is going to be 10 pies. So that's going to be x, again x plus 10 into x minus 5. So x equal to 5 is what is your answer? Because x, as x can't be minus 10. So now what you get is f double dash. So whole thing is that to find f double dash of x, find f double dash of x. X is 5, but f double dash of x, we have to show maximum. So that is the reason we are going to do. F double dash of x is 10 plus x into u dash or u v dash will be first minus 10 minus 4x. This is u dash. So sorry, u v dash plus u dash v. U dash is just 2 into 10 plus x to 1 into v is 100 minus 10x minus 2x. Okay, f double dash, now you have to substitute pi. Substitute f double dash of pi. Substitute, this is 2 into 15 into this is 20 minus 10 into 20 minus 30. This total negative plus 2 into this is 100 minus 10 pi is 15 minus pi square is 52 is 100. Pi square 52 is 130. This is also negative. So negative, negative is negative. So
Yes, sir.
what is the conclusion?
Sir.
Yes. Double dash is
Less than 0. So you'll get it as maximum at 5.
double dash of this is less than 0. So finally, less than 0, that implies what? F is maximum when x is 5. So F means what? A square is maximum when x. That is what A is maximum when x 1. So A is maximum when x is 5. So we have to find the area of the trapezium when it is maximum. Therefore, area is half A plus B x. So now find the area of A plus B is 10, that's about 20, all 20 plus 2x. 10 plus 10 plus 2x. 20, 2 into 2 into x. What is x? Root of 100 minus x square. What is x square? 5 square. This is what is the answer. So this is going to be 30 minus 15 into the root of 72. So 5 root 25 square units, square something, centimeter square. All right.
Yes, sir. Got the same answer.
Yeah, good. So I think you got it right. So you got the idea?
Yes, sir.
Here, if you do, see here, if you do first derivative like this, without squaring, if you do this, then what's going to happen? See, ax you got the same thing, area function you got the same thing, but if you do this directly, then what is going to happen is root will come in the denominator. That makes the question complicated. See, x is minus 10 is not possible, so x equal to 5 is okay. X is 5 you got, but double differentiation, see how complicated it is. Okay, very complicated double differentiation.
Yes, sir.
That's the reason square on both sides. It makes easy. These are only these two questions are very, very, very important. That's the reason I'm making you do. So we'll do this one. This one we'll do and then stop. Okay. Anyway, this is solution is there, but we will do one time. So that Yeah, prove that the radius of the right circular cylinder of greatest curved surface area. Curved surface area here, right? Curved surface area. Okay, maximum. Greatest means what is maximum? Prove that radius of the right circular cylinder of greatest curved surface area, which can be inscribed in a cone. Circular cylinder inscribed cone is half of that of the cone. Curved surface area maximum implies what you have to show? Radius of the right circular cylinder. Radius, right circular cylinder radius R we take. Is what is
Yes, sir.
of that of the cone. For cone ka, so okay, R of cylinder and R of cone. This is what we need to say. This is cylinder and this is cone. Okay, CO, right? Okay, radius of cylinder equal. So like this, now we can draw right circular cylinder and drawing this. And I inscribed inside I put, okay, right circular cylinder. Like this I put. We can put many, but we want maximum one. Maximum one, right? So like that it's going to be. Right. You understand? Actually, see, we can put many. So like this also, we can put like this also, we can put. One cylinder, we can put like this also, we can put. Like this,
Yes, sir.
like this also we can put. You understand? Any cylinder we can put. We want maximum. Maximum means what? What should be?
But CSA should be maximum.
Yeah. Curved surface, it should be maximum. We have to put such a way that surface area of the cylinder is maximum. So what is curved? See and write. Curved surface area of the cylinder. What is that?
2 pi RH. 2 pi RH.
2 pi r. It's good. 2 pi r which is the curved surface area. This is maximum. So what is given? Which can be inscribed with given cone. So cone is given. Cone is given. So cone is given means what is fixed here? What? Yeah, what is fixed?
Height?
Oh no.
L?
Even cone means what? Yeah, height is fixed and radius is fixed.
Yes, sir.
See, I'm drawing here. This is what is. We'll take.
So, but radius will be dependent on the cylinder answer, no, sir?
Yes, cylinder word. Don't worry about it. Even cone is fixed. Even cone means what? They gave a cone you. They gave you a cone. That is everything is.
Yes, sir.
A cone. Let's say this is base radius is a caplar. So height, let's say the height is there. That is what. Let's say the height is capital H. For this small h we have taken. So I have taken this one. You understand? Everything is fixed.
Yes, sir.
Volume is fixed, right?
Oh, right.
Volume is constant, like that. So volume. Volume of
1 by 3. 1 by 3 pi r square h.
This is what is fixed. Okay, we'll take capitals we are taking because cone is bigger one because we are inscribing circular cylinder in cone. So cone is big one. So therefore, so we have taken capitals. So pi r square h because these are constant. So this is now is capital. Okay. So with the help of this thing, what we should do? We have to convert this into one variable. But you see, small r, small h is there. Capital H is there. So this is what is very important to understand. Very, very important. How do we get relation between capital cap h, small h, and not only that, you have to remove this small h r, okay, with the help of volume. So now let's see here, what is the relation here? See here, I will, just you can see here, two diagrams are there, One is this. I'll put A, B, C, here, A, B, C, E, D, and E I'm putting. Okay? Understand?
Yes, sir.
D.
Yeah.
I am putting this one is D point. So A, and not only that, and we'll put this one D, E, F, G, like this. That means what? A, D, G. You see, A, D, G. Okay? This is the triangle A, D, G. And A, D, G. And also big triangle we have. What is that, Big triangle we have. What is that big triangle? This is what is
AC.
AEC. This is what is big triangle. These are similar because this vertical angle is same. And this is also 90 degrees. Therefore, by AA similarity. AA similarity.
Yes, sir.
That is the reason this is important question. You have to get into this point. Okay, get to this point. So A by A similar to what you can say is AEC is similar to ADG. Understand? So that means what, this is total is H, total is H minus small h. Okay, this is
Yeah.
what is small r. Okay, this is what is capital R. Got it?
Yes, sir.
Now, h minus small h by capital H. This by this equal to small r by capital R. Yes or no?
Yes, sir.
Now you have relation between capital H, capital R, small h, small r. From this, we have to eliminate what? What we need to eliminate in this?
Capital H.
Why? What is our aim? Our aim is to convert 2 pi r h into one variable.
Yes, sir.
That means what? Either r or h you eliminate. But
Oh, right.
what's the point in eliminating r? Because you want r only, na? R only you want, na?
That's
Two
so that's why I said H.
Yeah, yo, acha. HL. Yeah, good. So therefore, small r equal to 2 r. Yes, sir. We are assuming, right?
Yes, sir. Yes, sir.
So therefore, yeah. So therefore, we have to eliminate. So further, no. Okay, this will take some space here. We'll take some space here for remove of this one because then that one is done. So okay, all right. Then we'll take a small cap. This h small h actually we need to remove. So take this cap h that side h minus, yeah, here take h minus h is equal to hr by capital R, and then we want small h, we want that is capital H minus small hr by r. This is what is the thing. Therefore, finally C is 2 pi r into this is h minus hr by capital R. Understand? What is,
Yes, sir.
so now C is what is function in R. So CR will write. Understand? CR. Okay, let C equals here. So take inside 2 pi hr minus 2 pi, okay, 2 pi r square, but h by r is constant, h by r, 2 pi h by r into r square. So now what c dash of r? What is that c dash of r? 2 pi h, r ka differentiation 1 minus 2 pi h by r, r square differentiation is 2r. So Now C dash of R is 0. Will give you 2 pi h minus 2 pi h by cap R into QR is 0. Will give you 2 pi cancel. Yeah, h2 pi h cancel. And 1 minus 2r by cap R is 0. That will give you 2r by cap R is 0. That will give you small r is, oh, what is that? We got somewhat different. Yeah, cone is Kepler, yeah. Cone is Kepler, this is smaller. This is smaller, cone is Kepler, yeah, r by 3. So therefore, small r equal to Kepler by 2, but we'll see then f double dash, c double dash of r, we'll see now. C double dash of r is what? This is what is 0 because it's all constant minus. So 2 pi h by Kepler into 2. What is 0? Even if you substitute small r is not there. Okay, if you substitute r by 2 also same thing. So therefore C is what is maximum when small r equal to Kepler by 2. Okay. In this question, you will be able to do everything, but this is what is the point here. So this is what not usual, general way of doing. And this is what is an important point.
Oh, this is so.
All right.